Well, hopefully it will. So this one, we do have a number 1, and we got some index and exponent right there. But I can't really simplify from just the numbers, right? So what I would like out of this, because, and that's kind of a large index right there. It's really not a problem, you guys, because what I'm going to do is I'm going to make that, I'm going to show it as j to the power of 6 over 13 right there. What I would like this to be is j to the power of 1. So, you know what, I might have to do this 2 different ways, or show it 2 different ways, but it's the same thing going on. Now, if I were to make this j have a power of 1, which is what I'm going to do, what do I got to apply to my 6/13ths? Well, you'd have to add in 13ths 7/13. How did I know that? Because 6 plus 7 is 13. This would then give me j to the power of 6 plus 7 is 13/13. And 13 over 13 is 1. Okay, now that's applying that to the denominator, but if I do it to the denominator, I must also do it to the numerator. Doing that, though, would mean I'd have to take the 1 and multiply it by j to that new power, 7 over 13. Now, this is strictly using exponents right here. The other method is to use the actual roots, which I will show. So now I've got j to the power of 7/13 over j to the power of 1, which I will now show is just j. Boom. Now, that's good enough for me, but what they probably want here, since we started with a root, is an answer that also has a root. So I've got my j there. So this would be, it's going to be the 13th root of j. That's correct, j to the power of 7 from the numerator on the exponent right there. So I believe that's what they want. I believe they want this one. It's possible they want this one, but they did say to rationalize the denominator on this one. So that rationalizes it. I almost want to say that it would accept both. I just can't confirm that it would. But either one of those would work. Now, the other way, like I was saying, so let's go back to the original. So we had 1 over the 13th power of j to the power of 6. So what I did there, this part right here, you would need, so I'm going to show, again, probably more work than you'd want to show, but if I multiply this by the 13th root of j to the power of 7, see, now I can I'm still working in the denominator, by the way. It's just if I do it to the denominator, I got to do it to the numerator as well, right? So that'd be 1 times the 13th power of j to the power of 7 as well, which we see in this numerator, right? So how does this stuff become just an individual j? Well, in the bottom there, now that I have matching indexes, what I can do is just make it one individual index of 13th root of what would be j to the power of 6 times j to the power of 7. And there we can see then that we can add those exponents together. So it ends up being the 13th root rather, of j to the power of 6 plus 7 is 13, because we're adding those exponents. So 13th root of 13 exponent gives us just that regular j to the power of 1. So that's where that j came from. Or this one, whichever one you're looking at. I could show more work here, not that I think you want me to. But, right, so that would have equaled, you still would have had the 13th root of j to the power of 7. And then finally over here, still with that numerator, the 13th root of j to the power of 7. But this part right here, 13th root of j to the power of 13 just ends up being j. And again, you see this format at least is still written like this one. Same thing, I suppose it actually is the same work, just shown with roots instead of exponents. It's up to you.